Oh, okay.
So you are basically asking the computer to give you a space in memory. Then you are telling the computer,
Okay.
that's what this var keyword is for. You're asking for a place in memory. Then you are telling the computer,
Okay.
that, okay, in this space, store this value. You are storing this string, Jamie. Then you are now giving that space a name. So you can get the analogy. You're asking for a space in memory.
Okay.
We are giving this name called name. You can basically name it anything. You can name it T or anything you want.
Okay.
But there are some names you can't name the variable. We'll get to that later. Some special key.
So wait, when you say memory, is it like you store it like forever?
While the program is running.
Oh, okay. So those are basically like important things.
Yeah. You know, in computer memory we have RAM. Yeah, RAM is like for when the application is running. Those sort of this sort of data, they get stored on the RAM while the program is running. You get it?
Okay.
So you're asking for a space in memory. You are giving it a name. Now I'm giving it J, and then I'm giving it the value. Okay. So you are assigning equal to here. Here, where what equals to mean is that you are assigning the value, this value, to this variable. So you get it? So you have a space in memory. You are assigning the value to this name.
So what's the essence of it to your code?
So now anywhere in my code, I can just reference this value by using J.
Okay. Oh, okay, now it makes sense.
So now here I can just say print J.
Print J.
Then it gets run to print Jamie. You can say, hold on. So you know here you asked that, can we print it before? It's not possible.
Yeah.
We can't print J here.
Okay, because
reason why, because you know that runs its own program from top to bottom. So when it gets here, oh, I'm inside the void. Oh, let me print J. Oh, what's J? It doesn't know what J is.
Right, it hasn't gotten that level yet.
Yeah, it doesn't know what J is right here. Until it gets here, then J. Now we can use J. Okay. So now we can just print J anywhere we like. We can use J for anything we want right now. J, print J. So you can print it 2 times. You can see it's printing it.
Yeah.
So I wish we were using VS Code right now. I wanted to show you something here. When in VS Code, if you hover on top J, it will highlight something for you to say J is a string. You remember I said anything inside single is a string.
Single quote is a string.
Yeah, J is of string data type. So the data type of J is what is a string. So if I had written like let's say 23 here, J becomes a number.
Number.
Yeah. It becomes an integer. I mean, yeah, it's still a number, but it's an integer number.
Integer. Then if you put decimal, double.
It becomes a double.
Double. Yeah.
So now, you know, we used var here to create a space in memory to name our variable, right? We can so easily use the data type. We can say double.
So, I'm sorry. I'm sorry. So whatever you use J, whatever you store, the value of J is, be it boolean, what? Please, what is this called?
Boolean. I just say
boolean. Okay. Even that one says add. Bool. Okay. Bool, numbers, string. You can work with any of those.
Yes, but you can't mix. You can't mix that type. You can't mix any data type together.
Yeah. Okay, I get. Okay.
I'll get to that in a bit. So you know we said you can use var here. You can use double because this is of type double.
Okay.
We can use, if we say this is a string now, to give us an error message. Because we mentioned that J should be of type string, and now we are now assigning a double type
number and
a double
string.
Type. So it won't allow it. So we can put it inside a single quote. It will allow us because now it's not a string.
Okay. So you can replace var with either string as long as the equals to value is string.
Yes,
as long as quotes.
Yeah, as long as the value at the right of the equals to is equal to that type that you are naming it.
Okay. So Boolean
yeah, Boolean.
Then inside too should be true or false.
Yes, exactly. So now we say this is a bool now, it won't allow us because you are saying J is a bool.
Yeah. You are mixing with double.
So now you have to say
numbers.
You have to say either true or false here.
Or false.
You use true or false here. So now what I didn't mention, when we use var, you can use var for any type. We have something we call
multi-purpose.
Yeah, we have what we call type inference. Type inference means that we are basically telling that DART. You are basically telling that figure out. Hello. Can you hear me now? Hello.
Hello.
Hello. Can you hear me now? What's wrong with this service? Hello. This one should just send me a card. I just use my AirTag. Just went to my number. This is hello.
Hello, I can hear you.
This is so much.
Hello.
Hello, can you hear me now?
I can hear you.
I think you have to. You just have to be with me. So is it?
No problem.
I said we have something we call type inference. That what this means is that you are telling that if you are using if I'm saying that and that, they are two different things. Or I should use phone, I should use Dart. So you understand the one I'm saying.
Everything goes.
So in Dart, we have something we call type inference. So you are basically telling Dart that please infer the type of this variable. We not specify the type here. We are using var. And specify the type explicitly. Like we can say string here, then J will be of type string. But now if we are saying var, we are telling that check the value here and then set the
Yes.
So that's why we are using var here. So you can just use bool. If you like, you can use bool. You can use anything, but it has to be the same. Once you use var here, this value can be anything. Then anything will be the type of that value, of that variable. You get it? So now it's basically just the same thing as saying bool here. And if you say this is now 4, you basically just say, if you say var, it's the same thing as saying
it's
int here.
Number. Okay. So basically, var allows the computer to read whatever type you put in there.
To figure out the type by itself. So that's what we call type inference. It's inferring the type for us.
Okay.
So now, hold on. So now we talked about basic variable declaration. This is what we call declaration. You are declaring the variable, declaring and initializing. Variable declaration and initialization. So now something else I have to mention. Here, we said, let me change it back to var. We said var j is equals to 4. If we print j now, it will give us 4 2 times, right? Because we are printing
4.
Yeah, 4 4.
Okay.
So now, if you use var for the data type, you can mutate the value. What do I mean by mutate? You can change the value as much as you want. Like you can see, okay, j now is not 4 anymore. It's now 56. You can see. So you've mutated the value inside J. If you run it now, J will give us
56
2 times. Thank you. But I didn't mean we put the print the print statement here. You know what this?
Okay, to bring out 4.
And then?
And then 56.
Thank you. So to bring out 4 here, because here,
And yeah,
at this point, J is still 4. But at this point, we mutated the value.
J is 56.
Now
Okay.
56.
True. Yeah.
So there's a difference between declaration and there's a difference between declaration and mutation. So here we are declaring J. We're asking for a space in memory.
Yeah.
Now you named it J. You know, here we mutated, let me take this out. Here we
so basically
mutated
changing
the value, yeah? But we cannot now say now var J again. Okay, hold on. We cannot say var J is equals to 56. Let me tell you why. We created a space in memory, we named it J. We gave it a value of 4. Here, remember I told you, if you use var or any data type here to declare a variable, it means you're asking for a space in memory. But if you just say J is equal to something, you are changing the value of that space. But here, you are creating another variable called J. But it's not possible because if you want to use J here, which one do you want that to use? That will be confused.
Yes.
Get it now. So that's why we cannot create another variable named J. Here you can see. Here in the same scope. We cannot create the same name, the same scope.
Yeah.
So now we can only mutate.
Like,
okay, go on.
And I said it's just like when you have a file saved on your computer file with the same name.
Yes,
it asks to replace.
it
won't allow.
But here it will not even replace. It no bother replace. To tell you to take one away.
Okay. Yeah.
Let me see. Let's read the error message now. Hold on. So you can see here it says error. The name J is already defined. Try renaming one of the declarations. So you can see the error message. So it's saying J is already defined. You cannot name another thing J. So you should change one of them. Use you here. There will be no error again. So now we've talked about mutation, declaration. This is not the only way to declare variables. That programming language is it has null safety, like I mentioned in the class yesterday. What do we mean by null safety? We have a type called num. You know, we mentioned we have string, we have int, we have double, we have bool. There's another type called null. So null, what null means is nothing. Basically, you have nothing. That's what null means. So if we print J now to say null, right?
Blank. Okay, to say null. So nice.
We have that means J is null, is nothing. There's a difference if in that null safety before last year, that does not support null safety. So you can basically declare anything that has null. But they upgraded and they included null safety. This is to help developers because null safety has caused a lot of crashes and all. If you've used some applications before, that when you are doing something, it just crashes and then exited. So it's because of all this null value. Because when the program is running, it does not expect null, and you are now referencing null, it's going to terminate. It's going to crash your program. So that's why sometimes null is bad. It's bad for your code. But because that included null safety, it gives us fine control on top of null. So if you want to use null, you have to know here, this value has to be null. So that means I cannot use it anywhere else. Or if you know that it's not going to be null, specify that yes, this value is not going to be null.
Okay.
So we can specify that string. We can say string. You know, if you want to create a variable of type string, let's name it name is equals to Johnny. You know, it's a string now. But if you want a variable to contain null, you can add the question mark. So that means name can be null. But you know, name already has a value here. It's not null. We know it's not null.
Yeah.
Yeah, but you are declaring the variable that it can be
Name
null.
it cause
Can be
okay.
null.
So will Jamil come out again? Like if you like run it?
Yes, it will come out. But remember, it's not a type string anymore. It is string, a nullable string. I don't want to confuse you. It's a nullable.
I'm confused.
Hold on, let me because this nullability and all this rest, even some experience.
Wait. The reason why I'm confused is that if null is causing all this chaos, why are you using it?
I like that. I like that question. You get to where you need null. Once you in some other classes, you get when you need null. But I just want you right now to know that
so understand,
yes, there's something called null now.
Yeah.
So when we get there,
Okay.
you will understand better. Right now, you should know there's something called null, and a variable can be null. You get. So name right now can contain anything and it can contain null. So it's not of type string anymore. It's just a nullable string. Also, you can even create an integer and say it can be a null. Let's say it is.
Okay, so if a string is equals to null, like the variable in it is like null, does that mean when you type in name again, you can put in any value? No.
Yeah. Okay. You mean you want to mutate name, right?
Yeah.
You can use any value.
Yeah.
In fact, you can now say you can say name is null now. So you get. You can say name is null now.
Okay. No.
But here it won't allow. Let me go back. Let me go back. You know, we said we can mutate any variable that we use.
Wait. Yeah.
Ask
okay, I'm listening. My question was because it's no longer a string, it's a null string.
Yes.
Yeah. So the name that is equals to the value Jamil, if you want to like reference it again, can you like put in another name since basically Jamil is like null?
Yeah.
Right.
Let me go back now. You know, we said here we are asking for a space in memory and we are giving that space a name.
Yeah.
So if you want that space in memory, you have to use that name, this variable name.
Okay. Oh, so the computer reads the null. It creates like a storage for the null too.
Yes. It creates a space called name, and that's data type. The data type of this name right here is a nullable string.
Oh, okay.
So now you see, if we can mutate it here, you see, I said name is equals to null. If we print name now here, you see we are printing name. It will give us null. You know, because we rename it null. But
you change
it. So here, you know, I said if you want something to be nullable, you have to use question mark, right?
Yeah.
So now if I take this question mark away, we are now saying that name can never be null.
Yeah.
So that's what null safety is helping us at. Automatically, any variable you declare without that question mark is non-nullable. Is non-nullable, meaning that you guarantee that this variable is going to contain a value. It will never be null.
Okay.
So now you see now we are trying to mutate name to contain null here. And it's not allowing us.
Accept.
Because it's a non-nullable string now. But once we put the question mark to allow us.
Okay. So the please.
Take it easy.
The null string. Null string, right?
Yeah.
Okay, so like basically making it a null string means that you can later on in the code change it to null.
Yeah, exactly.
But a variable that is not
non-nullable.
Not null, non-nullable cannot
can never contain a null value.
Okay. So basically you're telling computer that you're not sure if you might still change it to null or not.
That's why we're using the question mark. That means you're telling the computer that we are not sure later on that this name can later turn to null. We are not sure.
Yes. Don't save it, we're not sure.
So we are not sure. Don't save it as a string. save it as a non-label string. So now, if we remove the question mark, that's why I'm saying name will never contain none. But here we want to be taken. That's like, hello. Hey, I think the service is not again. Hello, can you hear me? Wahala. That's done. I'm having a dig because of this thing. Shall I go change the meeting, go another time like this? What is it now? Hello, can you hear me?
Yeah, I can hear you now.
Oh wow. I'm tired. All right. So I said, so you get that part right. Yeah. Difference between if something is nullable.
Yeah, I do.
So because this part, yes, this nullable and non-nullable parts, even experienced developers, when the Dart engineers introduced null safety earlier this year, even experienced developers were having issue like to catch up, to get along with all this null safety and stuff. Because it's just for us, it's to help us it's to stop us from creating any program that can later on crash. So we need to catch the bug right now when we are writing the code. It's better to catch it now than when you now deploy your app and your app starts crashing all over. So that will give you bad.
Yeah.
Right. So now let's continue.
Okay. And it won't be easy to go back to find where the bug is.
Yeah, it won't be easy to
without the null
at all. You have to like search, maybe you've written 10,000 lines of code now. You have to check everything, check where the error is coming from and all that. Trust me, it's not an easy thing. It's not beans. No, you mama. Hello?
Hello?
Yeah, I can hear you.
Please, please continue. I'm going to mute it because my grandma is speaking with me.
Right.
But I'm listening to you.
Well, I won't know when my network starts doing rubbish. That's the issue.
Okay, once I'll she just wants to tell me something. It won't take long, but I'm listening to you though. Okay.
So we have another way of creating variable. We have another keyword to create a variable. Let me take this way. Call it late. I just say late int num1 is equals to 45. So now what this late is for right now is to say, I said when you want to run your that program, that runs your program from top to bottom, right? So once it gets here, normally if you just say int n is equals to 45, here automatically when that gets here, it creates a space in memory, like I've mentioned initially, creates a space in memory. But once it gets here, because we are using late here, it won't create that space right now. It won't create it until when you want to use it. Now we are using the num1 here. So this is where the variable gets declared once you use it. The reason why we have the late keyword is because if you are running something intensive and you don't want it to run when something happens, or you only want it to run when something happens, that's why we have the late keyword. So it's not that you are now wasting memory for efficiency.
Oh my goodness. I'm not following. I'm sorry. What the hell?
All right, let me go back.
Oh God. Please, thank you. I'm so sorry.
Let me run the that program. Here, once it gets to this line 2, you are asking for a space in memory. Automatically, when you get here, that will create a space in memory and store the value.
Yes.
Give it a name, n, right?
Yeah.
But here, the reason we have the late keyword here is to say that, wait, don't create the space yet. Don't create that space yet. Only create that space when you use the variable. So here we are using the variable. Yeah, num1. We are using
Only create the space when you what? Use
When
the
you
what?
use the variable.
Oh, okay. I had your geology. Alright.
So here we are using the variable here, print. This is where the space will get created. Once that gets to this line, then it will only create that variable and then reference it. If we don't use that variable anyway in our code, the space won't get created. So you get.
This one is quite confusing.
Don't worry, you don't really
So,
need this one now. When we get to Flutter, we will use this a lot. Just to show you that.
yeah, but,
Oh, you have a
okay, but
question?
please just please explain it one more time, because it's better I learn it now, so it won't be like Japanese to me then.
All right.
She gets.
So when that gets here, it creates a space in memory. It doesn't wait.
Yeah.
Gets here, create a space in memory. It gets to line 3. You see,
Okay.
it has a late keyword. It has a late keyword. It doesn't create that space in memory. It doesn't declare the variable right here. It doesn't create that space in memory because it's for efficiency. For efficiency reason. One, because sometimes we don't use some values, and automatically that creates that space in memory. It doesn't consign that. Once you initialize or declare a variable, it creates a space in memory. But here we are saying, wait, don't create that space yet. Don't create yet until we use the value. So we are not using the value here, anywhere here. But that this code here, this variable declaration won't happen until you use it. So we are using it here. This print statement. This is where the initialization starts. When we use it here, then
it is saved.
Now it will now create that variable.
Yeah, it creates it. Yeah.
Normally, when we're here, it will create the variable here, line 2.
Yeah.
When it gets here, it won't create the variable here. It creates
until you use it, until you like initiate it.
Yeah. Until you use it.
Okay, then it's assured that you're good to go with it. Okay.
So that's just the function of delete key.
Okay. One question, please. When you initiate var, can you delete it
I don't get the question.
from the storage? Like, okay, so the computer creates a space for it.
Yeah.
So can you like delete it and tell the computer not to create a space for it, or does it like create a space?
I understand the question. You created a space already in memory. There is no deleting.
Yes.
Until the program.
Wow.
If you open an application now, everything about the application gets stored on the RAM. The RAM is like the working memory of your computer. Everything about the application gets stored on the RAM. All variable declaration, everything, every variable you declare, everything gets stored on the RAM at that point that the program is running. So once you quit the application or the application stops running, all those variable declaration and all just vanishes from the RAM. You get. So the memory we are talking about, when I said is creating a space in memory, the memory we are talking about is your RAM. You get. Is your RAM. So once you quit an application, everything about the application, all those variable you are setting, everything gets wiped off.
Okay. So in a scenario where you create a var and you don't intend to use it, does it affect the application?
In a way, not really, because that is efficient enough. There is something we call garbage collection. I don't want to go into the of it, but when we are using all those C++ and stuff, you have to allocate yourself. You have to delete memory. Once you are done with it, you have to delete. Like in C++ now, like you asked, you delete the memory, you delete the variable yourself. But other higher level languages, like all these DATs, the compiler does all those job for you. All those memory, we are not using this one right now. We are not using it anywhere here. It's even giving us a warning. Check the warning. It's saying the value of local variable n isn't used. See, that's it doesn't stop the program from running. When it runs, the compiler will just clear any variable you are not using. It clears it off.
Okay.
That's the difference between all this C++ and that. Because C++, it's you yourself that you have to call a function like, I want you to now delete this variable because I'm not using it anymore. But that compiler takes care of it for us automatically.
Okay.
All right.
Yes.
So now we have just 2 other keywords to go. After that, we are done with types and variables. Then we just go to operators. We just touch on operators a little bit. Now, the first keyword I want to talk about, final. We have this keyword called final. It's a way to create a variable. You can say final name is equals to Toby. I like your name. So yeah, don't forget, name is of type string. Yeah.
Yeah.
But what final means is that, you know, when we used var,
yeah,
we can mutate the value of name.
okay.
Yeah.
Oh, final, you can't.
Yeah. Final, you can't
Yeah.
mutate. Once you
You
set the
can't.
value, you can't. Let's change it.
Yeah. It means permanent.
Yeah, you can see.
Oh,
Don't allow us.
yeah.
The final variable
Oh, okay.
can only be set once. You see.
Yes. Yes.
We have another keyword called const. Const means constant. It's basically the same thing as final. It's the same thing as final.
Yeah.
Once you name something final or const, it can only be set once. You cannot set
Once.
it. You cannot mutate it again. You cannot mutate it again. So now the question is, when should we use final or when should we use const? In your data program, in any program you run, you know, and when I talked about computer languages and all, I said computer only understands binary, zeros and one.
Yes.
Right? So your code, your DAT code, let me see if I'm recording this session. Hold on.
Yeah, you are.
So your DAT code gets compiled to binaries. Compilation, that's the keyword. Gets compiled binaries that the computer understands. So when we run this right now, it gets compiled to binary. Then and only then can that run that program. So that's the difference between compilation time and run time. You get. So compilation happens first before runtime. So it has.
Okay, now that confused me. Everything you just said.
All right, let me
compilation.
Let me track back. So compilation just means that all this we wrote void main concon gets broken down into zeros and ones. So you get that.
Yeah, binaries.
Because that's the only language computer understands. If we don't compile, computer can't run this. It doesn't understand it.
Okay.
So we need to first compile it
before you run.
Yes. So it gets compiled.
Okay, so
yeah, ask your question.
So compiling doesn't mean like highlighting everything.
No, once you click on run, all that will happen.
Okay, it's automatically compiled then run.
So you get.
Oh, okay.
So
okay.
Compilation is different from runtime. So it has to compile first before it gets run. So all this error we are getting at compile time, so we are getting this error now. It's better to get it now than in the runtime. Like all those null something. That will tell us that it doesn't want null value. So that's compile time error. So it's better to have compile time than runtime error. Because runtime error, that means your program is running already. It's going to crash if you get any error. The program is going to. But compilation.
Sorry.
All right.
One question: if a program should crash, does it mean like final crashing, or you can go back?
You can just open it again. But once you do something else, it will keep crashing on that particular stuff. Like maybe your application has a button that once you press the button, it does something. But because that's an error there, if you click on that button, you crash.
It will crash.
Even if you open the app again, you click on that button, it will crash. So that because your code is already running at that time. It has already compiled and it's running at that time, so it will crash. So it's better to catch the bug at compile time than at runtime.
Okay.
So why am I saying this? because there is a difference between const and final.
Constant and final.
So if you use const, it means that anytime while this thing is compiling, even compilation or even running or runtime, this value must not
Okay.
be it must be immutable. You cannot change it. But if you use final, it means that if you compile this program, you can still change
Okay.
value while you are compiling. Only when you are running
Oh,
the
you
program
can.
that you cannot change the value.
Oh, okay.
When we get to Flutter, you get to appreciate this better. When we need.
Oh, okay.
But now just know that final is a runtime constant. Const is a
Okay.
compile time constant. So you get that's the
Yeah.
difference. Final is a runtime constant. Const is a compile time.
Okay.
For example, I just want to paint a picture here. Okay, you're writing something, Abby.
Okay, I guess. No, I'm not writing. I'm listening to you.
Right.
Don't worry, I'm listening.
So I said this main something is a function, Abby. So I will get when we get to function, you will know what.
Yeah.
I just want to paint a picture of when you can use final or constant. I'm sorry.
Okay.
Let's create another
Yeah,
function.
it's okay.
You see, the function is outside of the main method. But remember, I said anything
Yes.
that only runs anything outside the main method. But you see, hold on. Let's name the function t. It receives a parameter, integer parameter p. Now here, we just want to print out what gets passed into it. Let's create a final variable. And let's set it to parameter. And let's say print variable. So if we want to call this, if we run this, this is not going to run. It's not going to appear. You know, we are printing something here. It's not going to see. It has to be inside the main method.
Yeah.
You have to call, we are calling the function. They call it. You have to call the function here. So we have to call t. This is how we call the function.
Okay.
So, but it expects a parameter. It expects something. It expects an integer. So let's pass an integer. Let's say we pass 5 to it. This is what is going to happen. It's going to print 5. Because here, this is what we are doing. Let me break this function down. Here we are creating a final variable. And we are setting it to be anything that we pass inside the function. So if we pass 5, if we pass 6, even if we pass 70 or any integer number, this is what p is going to be. It's going to be whatever you pass with. So I don't want to get into it because we are going to.
But it's outside the function. How is it able to read?
Because we are calling it here. We are calling it inside the function. If you had called it outside, it won't allow.
Okay, so it doesn't have to do anything with the one outside.
Yes. When we get to function,
the T5 doesn't have. Oh.
You know the function name is.
Okay.
You can name it. You can even name it. I'll give it your name. If we want to call the function, we have to use the name to call the function. So it's only when we call it. Let me break down. When we run the program, it runs this line, final stuff. It runs here, it goes here, then it sees Toby because you are calling the function here. Once it sees Toby, now it's going to run Toby.
Okay.
So we are calling Toby inside the main method. But if we don't call Toby, nothing is going to run. Let's run it. Nothing gets run in the console. So now we have to call it inside the main function. But it's expecting an integer. Ask a question.
Okay. So if it's void Toby string p. I don't know what parameter is used for.
P. That means it's expecting a string. Let's say string.
Okay.
Toby. Now if we run it, it's going to print Toby.
Okay. But why is it why is it like this? Because you said earlier that Dart reads from top to bottom.
Yes.
Do you get? But this one is appearing from bottom to top and it's still able to read it. I don't know if you get me.
I get your question. But this is a function. We are going to get to function parts. What I'm doing here is just to paint a picture of when to
paint a picture. I guess.
when to use final or constant or const.
Okay.
That's why I don't want to get into.
Yeah,
it's just to show you something.
Yeah,
all right. So
okay,
this is just what I want you to get concerned with. So we are saying final.
Okay, the final.
Or a certain variable to be whatever you pass to it.
Okay.
That means when that is compiling this code.
Okay.
The P is not set. But remember that it's final. When it's compiling, it's not set. P has to be whatever you pass to it. So we can use final here.
Okay.
But if we use const, it will not even allow us.
Okay.
Not allow us because it's a constant. It has to be set even before you compile. It has to be set.
Yes.
All right.
Okay.
So that's why I have to use const here, final here instead of.
Okay. So basically, final allows more room than constant.
Yes. But the only room it allows is as long as the code is not running yet.
Yeah.
You can compile and you can still change it. But as long as it's not running yet, you can still change it. As long as if it's running right now, that means you can never change it again.
Okay. Oh, okay. Wow. Like ever.
Never. Even constant.
What?
Constant has more restriction.
Okay. So if the program should crash and you figure out that that's where the problem is, that means you can't touch it.
Let me break a misconception. When I'm talking about you cannot change it ever and all that, you can just basically just create another variable. It doesn't matter. It's just a simple.
Okay. Yeah, I just remember that you said something, I forgot what you called it, but something you delete everything that you're not using.
Yeah. Your compiler will just basically delete what you are not doing.
Yeah.
Delete
compiler. Okay.
Yeah, that's the difference between final and constant.
Okay.
You know, when I said okay, you can see, let's try something here. You know, we said we created a name called Toby here. You can even use you can use Toby, you can use name here.
Okay, yeah.
Reference that Toby. Because a name is of type string too. Do you remember?
Okay, yes.
So because this is expecting a string, so it will allow you here. Well, as soon as we take off the string and we see it's now 23. And again, let me tell you something. There's type inference here too. You see, we are not we are not setting the type here. You can set the type.
Yes.
But it's inferring the type. Now, name becomes a number, an integer number.
Yeah.
So that's why it's giving us an error here. If we read the error, hold on. You can see line 5 is telling us line 5. The argument type int can't be assigned to the parameter type string. Let me break it down. The argument type int, name is an integer, is of type int, can be assigned to a parameter type string. So that's what it's telling us. So you cannot put an integer where it's expecting a string.
Yes.
That's the error it's telling us now.
Okay.
So let me get rid of the function. So that's all about variable. Also, you can you can set the type if you want. Here, final. But you don't need it because there is type inference. That's to join it to just infer the type for you.
Okay.
But remember, if you say string here, it won't allow you. It has to be a string.
Because that's integer.
Yeah, so it has to be in a single quote. Then it will allow you. That's all about types and variables. So we are almost done. So we want to talk about operators now. This is where we stopped yesterday.
Yeah. Operators.
Hold on. The first one we'll talk about is arithmetic operators. We have all these normal basic operators that we know in mathematics. See, we have addition, we have add. This is the same. We have subtract, your normal subtract, multiply. We have this asterisk sign, divide, and modulo. Now, this modulo, it's used to get the remainder of something. Like you say, say 6 divided modulo 3 instead of 6 divided by 3. You say 6 modulo, the answer will be 0 because 3 divided by 6 is 3, remainder 0. So if you say 5 modulo 3, the answer is going to be 2 because 5 divided by 3 is 1, remainder 2. So modulo is just to get the remainder.
The remainder. Okay.
Yeah. There are some cases where we need this modulo. Like if you want to know if a number is an even number or an odd number. So you can basically just check if that number modulo 2 is equals to 0 or if that number modulo 2 is equals to 1. Because if you say something modulo 2 is equals to 0, that means that number is divisible by 2. It's an even number. But if that number is giving you something else that is not 0, that means the number is an odd number. So you get. If you say 2 divided by 2, you give us modulo 0, that's an even number. If you say
even number.
3, if you say 2 divided by 3, will give us remainder 1, Abby.
Yeah.
So that's where we use modulo. There are some cases.
So that makes it an odd number.
Yeah. So we use modulo sign, this modulo, to get the remainder of something. So let's see all this in action. So let's go back to our main method. Create our main. You can see. Print. Let's see print 6. So can you tell me if I run this program now, what will be the answer?
Sorry?
If I run this.
9.
No, think about it.
I think. Wait. This is a string now.
What happens in a string?
You're adding it now. What will it be? Are you looking for?
It's going to give us exactly what we wrote. You know, if we
oh my goodness, because it's a string. Oh my goodness. Yeah, it's not numbers.
Yes. So it's a string.
Oh my, and I said it, but you confused me. You're like, what happened if it's a string?
I just try to get something.
I understand, Jerry. At least I understand.
Okay. See, if we just anything we print inside the single quotes is a string. So it's just going to print it out exactly the way it is. Hey, I think this network is funny.
Yeah, it's a string like English.
Yeah.
Okay.
Can you hear me?
Yeah, I can hear you. So string basically is English, then
yes.
Numbers is maths.
Yes. If you can just think about it like that, your analogy to anything that makes you remember. All right.
Yeah.
We want to print 6 plus 3 is equals to. Now there's something I have not mentioned before. We call it string interpolation. If you want to do any evaluation inside the string, like if you want to say 6 plus 3 inside the string, you use the $sign.
Yeah.
Curly braces.
Okay.
Anything inside the curly braces gets evaluated. So what I'm going to say to print 6 plus 3 is equals to whatever
the answer.
whatever
9.
The result is.
Yeah.
Then to turn it into a string and print it.
No, okay. So you can still use string to calculate also, which is good.
Yes.
Because of the curly braces, yeah, $sign and curly braces.
Yes.
Okay.
There's something else. If it's only one value, you don't need the curly braces. For example, let's see. let's see, hold on. Let's see var n is equals to, let's say it's a string.
9.
Hold on, let me, 9. Here, we can,
So you just put n.
Yeah, if we say n alone.
It's not, it's just bigger n. So.
Yeah. So if you want to evaluate what n is, you can use
the dollar sign.
So because it's only one value, you don't the curly braces.
Yeah.
See. So you don't do, if you would like, you can put the curly braces on. To just save you a lot of time.
It's not necessary. Okay.
We're almost done. So yeah, you see, it's evaluating 6 plus 3 here. Let's copy this. Let's copy this again. Copy this. Press enter. Paste it. Now let's change it to minus. Copy, paste it again.
Multiply.
Paste it again.
Divide. Modulo.
The modulo is your percentage sign.
Yeah. Modulo equals to 0, even number.
Yeah. So if we run this, you can see 6 plus 3, 9, then 3.
Yeah.
10, so now if we change this to 5.
2.
Thank you. The answer will be 2.
Odd number.
Yeah, one number. Yeah, that's all about arithmetic operations. So we have the addition, subtraction, multiplication,
division, modulo.
So this is where we stopped in the last class with them. So I think that's the end of the class. So today we just talked about variable declaration, data types, talked about arithmetic operations.
Arithmetic operations. Okay.
You can just basically play with all this, play with variable declaration, with const, final, var, all that. See if you can mutate, if you cannot mutate, check all those things.
Okay.
Next class tomorrow.
Okay, thank you very much. Okay, then please, how do I go about the what's the name? Visual VS Code and the terminal. The Flutter the one that is not working.
Yeah. I think what I can do with because I'm looking at the time. I don't know if I can do that one today because you have to install Zoom on your PC. So I think that should be tomorrow, but it should be before the class. So what time do you have in
mind? Is it possible like an hour before the class?
I'm not really sure.
Or when would you be? Okay, when will you be free? Because I'm free tomorrow. Throughout. Yeah.
I think I have to get back to you.
I don't know.
You get.
You have to get.
So tomorrow, just message me on Slack, and if I'm not responsive, hello.
Oh, it's break.